Let's see, you want me to look at your answers and if you've got it correct?
Oh, we already did these. It's just I want to work on this because this is like what's on my quiz.
So you want to start on number 5?
Yeah.
Okay, in other words, you've already done 1 through 4?
Yeah.
And you're comfortable with your answers on there?
Yeah.
Okay, so let's use 5. Graph the linear equation using intercepts. Okay, so let me write on here. We got, hold on a second. So we've got x plus 9y equals minus 27. How do we find the x-intercept?
Make y 0.
Okay, good. What does x become?
1.
If I make y 0 and solve this equation for x, what do you have? What's 9 times 0?
0.
So you have x plus 0 equals minus 27.
Yeah.
What's x equal to?
1.
Well, that 0 is nothing. X is equal to minus 27.
Oh, yeah.
Where are you getting 1? The coefficient of x is 1, but x itself is equal to minus 27. So that's the x-intercept.
Yeah.
Now, what's the y-intercept?
Well, you get rid of x, which is 0, and then 9y equals negative 27. So you divide, and then that would equal 3, negative 3, I think.
Negative 3, fine. You did that perfect. Okay, now there's your 2 intercepts. I'm not even going to try to draw it on that graph.
Yeah.
I mean, if you want to, they haven't labeled the grid, so I guess we could label it in tens if you want.
Yeah.
Is that what they have you do? I think it's kind of silly myself that they don't label it. So the x-intercept is at minus 27 right there. The y-intercept is at minus 3, which is somewhere right there. Draw, connect the 2 dots with a straight edge, and there's your graph. Okay. All right. Let's take a look at this word problem. Everybody hates word problems, correct?
Yeah.
Well, what if I told you they were the easiest problems there are? You only have to do one thing. Define your variables.
Yeah.
Well, they've already done it. They got X shirts and Y jeans. So they've already told you, in other words, they've done the hard part. They've told you that X is going to represent the number of shirts you bought. Y is going to represent the number of jeans you bought. And you spent a total of $84. So write me an equation that represents the number of shirts you bought times the price of each shirt plus the number of jeans you bought times the price of each jean. All that has to equal, that is means equal, so 84. So tell me what that equation would be.
Well, I know it's going to all sum up to 84.
Well, you got to spell out the equation. What you got to do is turn these words into an equation. That's why everybody hates word problems, because they have a hard time doing it.
S12 plus...
Hold on. How much did you spend on shirts?
12.
Nope. Per shirt. How many shirts did you buy?
What? Well, you don't know. It's
You bought
$12.
X. If you bought X shirts, we're going to solve for X. You're right. We don't know what X is right now. But you bought X shirts. Each one of them cost $12. So what did you spend on shirts?
$12. 12 times X.
12 times however many you bought. If you bought 2 shirts, you spent $24. If you bought 3 shirts, you spent $36. So 12 times X represents how much you spent on shirts. How much did you spend on jeans?
28 Y. 28Y.
28Y. Jeans are Y. And that total is $84. Okay? Now, that's the answer to A.
Yeah.
Unfortunately, you can't solve that. Well, I can't believe they gave you this problem. I really can't. This is amazing. They give you a problem with 2 variables and only 1 equation. That is not solvable, except if you know that you have to have whole numbers. In other words, you didn't buy 2.5 shirts. You didn't buy 3.5 jeans. So you bought some small quantity. So we could play around with this. And let's see, if you bought, this is a terrible way to solve this problem. Let's see, maybe they're, they don't want you to solve it. That's the problem I'm saying. Yeah, this is not a word problem. They want to find out how many shirts you bought or how many jeans you bought. They want you to come up with the equation, which we did, which has got an X and a Y in it. That means we can graph it. Let's use our intercepts. What's the X-intercept?
12. And you could go up by, like, I think 2.
So the X-intercept, I'm going to let Y equal 0. Now I have 12X equals 84. What's X? What's 84 divided by 12? You need your calculator with you.
Mom, where's my calculator? Oh my gosh.
Always have your calculator when we have a session. 84 divided by 12 is 7. Okay? Now, what's the Y-intercept?
That's 28 divided by 84.
Other way around. It's 84 divided by 28. 3. Okay? So, if I assume that every one of these is 2, then I got 2, 4, 6, 7 is right there. And Y would be right there. So there is the graph of that problem. But that's all it is. We didn't determine how many shirts you could buy and how many jeans you could buy, which is unusual. Usually when you get a word problem, they want that information. But they had to give you a second equation to be able to get that. I guess what they're doing here is just making sure you can graph a linear equation using intercepts.
Yeah.
Okay? And that's a linear equation because, first of all, there's an X and a Y in it, and there's no X squared. There's no square root of anything. In other words, it's X to the 1 and Y to the 1. That makes it a linear equation, meaning that it will always graph as a straight line. And you can notice you can graph them by putting them into slope-intercept form and graphing them, or almost an easier way to graph them is this intercept. Notice that when you do the intercept method, you don't ever know slope. I don't know what the slope of that line is. I've never had to deal with it. The X-intercept gives you a point. The Y-intercept gives you a point. A straight line is determined by 2 points.
Yeah.
So I didn't need the slope. And you don't when you use the intercept method. All right. What else are we doing today?
We just like problems that are similar.
I'm sorry, what?
We just work on problems that are similar.
Well, yeah. I can make up problems and we'll graph them based on the intercepts. Yeah, let me do this. I always kind of hate to do this because I'm never sure exactly what they're working on in your class. Like when I saw that last problem, I assumed they wanted you to solve for x and y, and they didn't at all. That wasn't even part of it. So if you just want quadratic or linear equations to graph, let's do a couple of them. Hold on a second. And I'm going to have you do them both ways. All right. Do it the slope-intercept way.
Find the x-intercept, you make y 0.
No. Do it the slope-intercept way. The first three problems on that last page were solve it using slope-intercept method. So we're talking two different methods today. We're talking slope-intercept method, where you solve the thing for y. And we're talking x and y intercept method, where you merely solve for the x-intercept or the y-intercept. I want to do it both ways to show you that you can do it both ways and that they both produce the same graph. So, the first method, slope-intercept. You got to solve for y. Solve that equation for y. It's the first step of solving it for y. No, what is the first step of solving this equation for y?
Would I have to reorder it?
Got to get rid of everything that's not y. In other words, this is going to go through a number of steps, and I'm going to end up with y equals, and everything else is on the right side.
Yeah.
Okay? So, what do you have to do? You got to start getting rid of stuff. I got a lot of stuff on that's with the y.
We should have to subtract 2x and put negative 2x.
Okay, so let's do that. Where am I going to put it? Am I going to put it after the 12 or before the 12?
Before the 12.
Yeah, because that is getting closer to slope-intercept method. We know slope-intercept method is y equal mx plus b. Well, yeah. It looks like that looks like a b, only I'm not quite done yet. So what is y equal to?
Y is equal to 12, I think.
Solve this for y.
Oh.
When I say what's y equal to, I mean solve it for y.
I'm confused.
Okay, what do we have on the left side of that equation that's not y?
3. Oh.
What is 3 doing to the y? Is it adding? Is it subtracting? Is it multiplying? Or is it dividing?
Multiplying.
Which means I got to do what to get rid of it?
Divide.
And I have to divide both sides. And dividing both sides means dividing both terms on that right side.
Yeah.
So now what do I have?
4.
Go left to right. Start there. You got y equals what?
Wait a minute, I gotta go ask my mom. Mom, I need you. Sorry, I'm back.
No problem. So what do we have here? Last line.
Well, I know 12 divided by 3 equals, that's 0, so it's just...
Jackson, I want you to go left to right. I don't want you to go right to left. Math is done left to right. In other words, we have y, that's the far left term, that's this term. What we have next is that. Don't get out of step. Don't go solving that before you do that. Do things in order. With math particularly. So what is the next term? Minus 2/3 x. Notice I did not write minus 2x over 3. I pulled out that fraction because that's the slope. That is m. Now, what's 12 divided by 3? 4. Now we have it in this format precisely. I have a y equals some m times x plus some b. So what is m?
M is 2/3.
Negative 2/3. Do not drop negative signs. And what is b?
4.
Okay. So if I'm graphing that, I'm going to start at 4. I'm going to apply a slope of negative 2/3, which means I'm going to go down 2 and to the right 3. And there's my graph. Okay?
Okay.
Now, that was doing it by the slope-intercept method. Now I'm going to go back and we're going to do it by the X and Y intercept method, which was the second half of your homework, or the second half of your quiz. Was all about not slope-intercept, where you solve for y, but finding the X and Y intercepts. Whoops, I'm not going to erase that. I want to show you that that is the equation of this line. But we don't get the equation of the line when we solve for the intercepts. Tell me what the X-intercept is going to be.
Well, the X-intercept would be, wouldn't it be...
Make y 0 and then solve the rest of the equation.
Oh, jeez.
When you make y 0, that always goes away, no matter what that number is. Anything times 0 is 0. So now you have 2x equals 12. Solve for x and you have your answer.
Oh. 6.
Now tell me the y-intercept.
4.
Good. Now, if I graph that, guess what? It's this graph exactly. Remember the y-intercept was 4 right there?
Yeah.
The x-intercept we know is 6. So if I graph this line based on these intercepts,
yeah,
same line. Now, this method was a little easier, don't you agree?
Here. Yes.
But it's not always. In other words, if I give you something like this, now it's not so easy. In other words, nothing divides into anything evenly. So when I go to find my x-intercepts, it's going to be a fraction. When I go to find my y-intercepts, that's going to be a fraction. And plotting fractions on grids is tough. So when you get a problem like this, it's going to be easier to solve. I can solve that thing almost in my head. Slope of minus 3/5. Y-intercept 17/15 or 17/5. So I was able to do that really quick by using the slope-intercept method, meaning you got to solve for y. So those two methods are what you want to think about. Is just look at that homework page you were looking on. The first 4 or 5 problems were all slope-intercept. The next 3 or 4 problems were all X and Y intercept. Don't get confused by the word intercept, as in both.
Okay.
Okay?
Okay.
All right. You know what I want to work on for a few minutes?
Yeah. Is it that,
You got it. You know what I'm going to open up. I want to make sure you're getting better at these. I don't want to, and that'll tell me that you're working at it. As opposed to, if you're not working at it, you're not going to improve. We don't spend enough time on it in our sessions to really help much. But wherever I see you make a mistake, at least I can correct you. You yell out the answers, I'll type them in.
Wouldn't it be 9?
Now, let me say something first. Unless you can do this problem in under 3 seconds, you need to work on this page a lot. This is not a problem that should take you more than 3 seconds. If it does, you can do it faster on your calculator. And that's the whole reason I want you to get good at this, is so you can do it faster in your head than you can do it in your calculator. But most importantly, I want you to understand how you subtract a negative number. I don't think you understand how to do this one. How do you subtract a negative number?
When you turn one of the numbers to a positive?
You change it from a subtraction problem to an addition problem. How do I do that?
Well,
which is the subtraction sign?
The negative 12.
No, that's the negative sign. You just said negative 12. That's the negative sign. What's the subtraction sign?
The subtraction sign is the one right between 12 and 3.
Okay. So the way you do subtraction is you change them to addition. But because I did that, what do I have to do?
You have to turn 3 into a negative, I think?
Not the 3. What follows the subtraction sign? So I have to turn that into a plus also. That's it. You change the subtraction sign into an addition sign, and then anything that follows that subtraction sign, change the sign on that. In other words, if I have 7 minus 9, okay, this is a positive 7, subtract a positive 9. Well, I'm going to turn it into an addition, only now I'm adding a negative 9. That's how you do all subtraction problems. Simple as that. But you got to remember the technique. So, what is 3 plus a plus 12?
Isn't that negative 15? Oh, well, no, that's just 15.
Okay. Go ahead.
90. For my one, that's 3.
Okay. I hope you're not counting on your fingers, right?
Yeah.
I don't want you. If you find yourself counting on your fingers, stop immediately. Don't do that. Memorize. Memorize that 4 minus 1 is 3. I'm not starting with 4 fingers and taking one away. I'm memorizing that 4 minus 1 is 3. 5 minus 2 is 3. 6 minus 3 is 3. That's what I'm doing. That's what I want you to try to do. So don't count your fingers or use a calculator.
Mm-hmm. Oh, 11 minus 3 raised to plus. 19.
Perfect. Now you're catching the hang of it. Now,
oh wait, that's 83.
This is a subtraction problem, but it's not really one that you have to go through that technique. In other words, when you have a positive number minus another positive number, which is what this is, you know, just subtract the two numbers, you get 3. But when you have a bigger number subtracted from a smaller number, it's got to be a negative. Has to be.
It's negative 3.
Yeah. Okay.
That's 1. Actually, no, it's 0. Oh, yeah, it was 1.
No, it was 1. 1 plus 0 is 1. 1 times 0 is 0.
It's 6.
Again, you'll get to where you memorize that. You won't have to use your fingers. You'll just automatically know that 11 minus 5 is 6. It'll register without even you trying. The only thing you need to do is drill. You need to put in some time on this program.
All right, 0. Negative 11.
Negative 11. When you add two negative numbers, you just add the numbers and the sign carries forward. I want you to give me the sign first. On all these multiplication and division problems, give me the sign first and then worry about the rest later.
Wouldn't it be positive?
No. Negative times a positive is a negative. A positive times a negative is negative. Positive divided by a negative is negative. The only thing that's positive is if the signs are the same. Here, the signs are different. One is negative, one is positive, therefore it has to be negative. Now what's it's 4 times 5.
20.
Okay, now here we got all kinds of negative signs, subtractions, everything else.
Is it 6?
Perfect.
1.
Nope.
19.
Nope.
Or negative 19, I think. Oh, well, that's just negative 8.
Okay.
Is that negative 22?
No, we're adding, not multiplying. Always make sure you know what you're doing in terms of whether you're adding or multiplying, because they're very different.
Okay. 13.
No. When you're adding a positive number and a negative number, subtract them.
Oh, that's 9.
Put the sign of the bigger number. In other words, I'm going to subtract these two numbers, 11 minus 2, that's 9. And the sign is, well, the bigger number, the 11, has a negative sign. So it's got to be negative 9.
Yeah.
Okay? All right. Work on this page. I'm going to let you go. And I will talk to you next time. I want to see you get good at this.
Okay.
Your math will improve by 100%. If you're getting a D, you'll go to a B. All you got to do is get perfect at this. But I can't do a Vulcan mind meld. You got to do the work. That's the only way you're going to get perfect at these.
Thank you.
You're welcome. Talk to you next time, Jackson. Bye-bye.